We have so far shown the implications of our 5 basic assumptions about tastes on the shapes that indifference curves must take. We've also said that logically it is impossible for indifference curves from the same tastes to ever cross one another, and that furthermore there must be an indifference curve that passes through every single bundle that a consumer can imagine. This leads us to thinking about what we'll call indifference maps, where the entire map of indifference curves is really what is used to represent the consumer's tastes. We'll begin with our usually shaped indifference curve, but now we'll attach a label to that indifference curve, a numerical label that indicates how many udels, or units of happiness, the consumer attains if she reaches this indifference curve. When we use this label, we're assuming a particular ruler with which to measure happiness. As we'll see at the end of this animation, that ruler is arbitrary, and this number could easily change. We can then pick some bundle A that lies above this indifference curve, and draw an indifference curve that goes through bundle A, and therefore indicates another set of bundles that the consumer would be indifferent between. We'll attach the label 2 to this indifference curve, indicating that the consumer gets more happiness on the magenta indifference curve than she does on the blue indifference curve. Similarly, we can draw a third indifference curve that lies above the magenta indifference curve. We'll put a label of 3 on this one, indicating that any bundle on the green indifference curve is preferred by this consumer to any bundle on the magenta indifference curve or any bundle on the blue indifference curve. And we can keep going this way. There's some bundle E that lies above the green indifference curve, and of course there's a set of bundles that are indifferent to bundle E, and we can indicate that with another blue indifference curve, this time using the label 4 to indicate that all the blue bundles that we've just drawn are preferred to all the previous bundles we indicated. And we can keep going and do the same thing for another magenta indifference curve, to which we attach a label of 5. By now you get the point, but just to drive it home, we can draw 2 more indifference curves, another green and another blue one, but differentiate those from previous green and blue ones by again indicating a higher number next to the indifference curve to tell us that the consumer would prefer to be on these indifference curves rather than the earlier ones. Of course, the complete indifference map would also contain lots of indifference curves between these. We can never draw all of them since there's an infinite number of indifference curves for someone's tastes, but we just draw enough of them to get a sense of what the map looks like. Now, economists don't actually believe that we can measure happiness in any objective way, that there is such a thing as a udel that you and I can agree exists. The numbers that we put next to indifference curves are therefore not really meant to objectively measure happiness. Instead, all they are meant to indicate is which indifference curves are more preferred and which are less preferred by the consumer, with higher numbers indicating more preferred bundles and lower numbers indicating less preferred bundles. We can therefore change the labels on these indifference curves. We can multiply them by 2, or divide by 5, or add 13, or do any number of things to it. As long as the ordering of the numbers remains the same, we will say that the indifference map represents the same tastes. This is because the marginal rates of substitution at every bundle will remain the same as long as we don't change the shapes of the indifference curves. And the only thing the numbers tell us is where we go to become better off and where we go to become worse off. There is another way to think about what these numbers next to indifference curves mean. Instead of beginning with indifference curves, we could begin with what we call a utility function to represent tastes. A utility function is simply a mathematical object that tells us for any bundle how much utility or happiness the person gets at that bundle. If more is better, then this function will slope up, just like a mountain slopes up. And just like we know how to represent a mountain in 2 dimensions, we know how to represent this utility function in 2 dimensions. Think of a mountain first. You've done this in grade school, where you looked at rings on a map, and you knew that these rings on the map were elevations of mountains, and as those rings became narrower and the numbers next to them became higher numbers, you knew how to interpret that as an upward sloping mountain that eventually reaches a peak. It didn't really matter whether those numbers were measured in meters or in feet. The rings on the map remained the same, their shape remained the same, just their label changed. The same is true for a utility mountain that indicates as we get more stuff, we become happier. We can measure that happiness in various ways. But the sets of bundles that we're indifferent between don't change just because we change the ruler we use to measure happiness. If you're using the version of the textbook that contains calculus-based Part B's to the chapters, then you can go to Animations 4.8 through 4.11 to get a better sense of this. If you're using the version of the textbook that does not contain calculus, go to the Exploring Relationships tab on the website and explore the relationship between utility functions and indifference curves there.